welcome and good morning in the next lecture of the radar and TV engineering. Today we will discuss about the CCTV or CCD cameras and picture tubes. In last lecture, we have already discussed about the TV transmitter and the TV receiver system. In the TV transmitter section, we have already discussed the each section of transmission system or fundamental of the TV transmitters. And in the next section, we have discussed the receiver section. In the receiver section, we have discussed about all the type of blocks of receiver system, all in component of the receiver system. Now we have the main part of the TV system is the camera tubes. In previous lecture, we have already discussed the types of the camera tubes and picture tubes. Now we will discuss today CCD cameras and picture tubes. So cameras is used in to capture the pictures, and the picture tubes are used at the receiver sections. The content of this video lecture is the CCD camera, picture tube, types of the picture tube, construction, working principle of the picture tube. The main objective of this video lecture is to understand the basic fundamental of the camera tubes, to understand the basic concept of the picture tubes. Students will also learn about the working of the picture tube. They will also learn the concept of the picture tube and camera tube, working, construction, and types of the camera tube and picture tubes. The outcome of this video lecture, student will understand the concept of CCD camera. They will also learn the picture tube. Student will also learn the picture tubes with the types of the picture tube and advantages and disadvantages. The textbook for the radar and TV engineering, to understand the TV engineering is the second part of our syllabus, that is the monochrome and the color television, second edition by R.R. Gulati. Other reference books is given for TV engineering. Now we come to the main part or main things of TV transmitter, that is the camera. The main part of the CCD camera is the CCD image sensors. This type of the image sensor, it sends the image. CCD consists of very closely packed MOS capacitors formed by the P substrate SiO2 and the metal gate, which can store or transfer the analog charge signals. The CCD is composed of precisely positioned light sensitive semiconductor elements arranged as row and columns. Each row in the array represents a single line in the resulting image. This is the diagram for the CCD camera. This is shown the how the charge is moved from the plus V to lower, and the working of this CCD is the application positive potential to the gate. Result development of the depletion region just below them. When we apply the positive voltage to the gate, so there is the depletion region is formed, potential valve just below them. When any image is focused onto the silicon chip, electrons are generated within it. The number of the electrons depend on the intensity of incident light, and hence depth varies according to the applied voltage. The number of the electron depends on the uh, intensity of the incident light, and hence the depth varies according to the applied voltage. Once reduced, they collect in the nearby potential wells. The charge of the one element is transferred to the next element by applying a higher voltage to the next gate and reducing the voltage of the gate. The gate electrodes operate in group of three. For good resolution, we assign a three capacitor pixels. The charge transfer is carried by the multi-phase clock applied to the gates. After one complete clock cycle, the charge pattern moves from one stage to the next as an analog shift register. CCD camera, the sensors and vertical shift register, horizontal shift register, output. This is the image of CCD cameras, and that sensors are arranged with the vertical shift registers. Sensors are connected with the shift register, and horizontal shift registers is connected with the vertical shift register. Scanning steps into the two integrate period. One set of the electrode is supplied with the constant voltage, creating a deflection vision. Duration 1 to 10 seconds. Without period, phase clock pulse applied to the transfer stored charge to storage section. Duration is 100 microseconds. CCD sensors fabrication method. The frame storage transfer mode, interline charge transfer mode, and frame interline charge transfer mode. So here the how the sensor sends the image and they convert it into the output of camera is given by this image. So this is the photo sensors, vertical shift registers, and we have the horizontal shift registers and the amplifiers. The photo sensor sends the image, and the image is given to the vertical shift registers. Correspondingly, we have a horizontal shift registers and amplifier. So output of the shift registers is given to the horizontal shift registers, and it is goes to amplified. So finally, we get the amplified output of the CCD sensors or CCD cameras. So image is converted into the electrical signal. Here, the picture shows that the yellow light is illuminated, and step by step it is goes to the electrical signal. How the process is followed is given by this picture. So through this system, we are able to understand that the image is converted into the picture, electrical signal, or any photo is converted into the electrical signal by the CCD camera. The CCD image scanner consists of a large number of CCD devices arranged in the rows and columns to form an image area. Individual lines are addressed sequentially using an address register. The output circuit will contain the electrical representation of the picture information. It does not need an electron gun beam, high voltage, or vacuum envelope of conventional camera. For interlaced scanning in cameras, the charge transfer to the vertical shift register is accomplished in two stages. The odd number rows followed by the even rows. Next, the charges in the vertical register are shifted into the horizontal shift register and clocked to the CCD output. All the odd rows are clocked out first or filled, followed by all the even rows even filled. The rate at which the charge from the horizontal shift register is clocked out is governed by the number of the element pixels per row and video standard the camera complies with. Advantages: the CCD camera is the high sensitivity, image lag absent, means lagging of the image is absent in this because it has high sensitive type of the camera. The spectral response is very good. Sensor withstand excessive illuminations. No geometrical distortion or non-linearities. Lightweight and low power. Limitations: requires the external processing unit, relatively high power consumption, expensive. So these are the some limitations for the CCD cameras for image scanning that requires the external processing unit, uh, high power consumption, and the extensively expensive. The main application of CCD camera, it is used in the barcode scanners. It is used in the scanning of barcode at the malls, at the shopkeepers, or in the library. Camcorders, it is used as a camcorder to convert the image into the code form, and fax machine. It is used in the fax machine also. So these are the application area of our CCD cameras or CCD camera. Video processing of the camera pickup signal. How the video is processed by camera pickup signal. The optical image is focused by the lens on the glass face of target plate. The lens regulates the light by the iris built into the lens housing. The output of video signal is taken across the load register. So this is the image, how the video signal image is processed and converted into the video signal by CCD or any type of the camera tubes. So light is come from the scene and lens is converted into the parallel wavefront into the wavefront of electron beams, and it is given to the camera tubes. So camera tube is having a anode and cathodes, and electron beam is passed through this. Electron beam is focused on that anode, and we have a signal which is applied to the preamplifiers, which is amplify the signal level, and signal processor unit is there to process the signal, and sync added here. The synchronizing pulses is added, and correspondingly we get the video signal output. So video signal output combine the composite signal, that is the blanking pulse and the sync pulse and the video signal. So this is the electron beam scanning in the camera tubes. We have already discussed how the scanning of the electron beam is occur in the image processing unit or image sections. Amplify the weak low voltage signal from the load resistance RL, addition of the blanking pulses, addition of sync pulses. So in the amplify section, after amplification, we add the blanking pulse and the sync pulse in the corresponding video signal. The signal current or voltage across the load resistance RL. So if P amplifier is used at the first stage, the output terminal of camera tube to avoid external interference. The second stage, we are using the signal processors to add a blanking rise during the horizontal and the vertical trace interval. Sync adder circuit is used to add the synchronizing pulses. The output waveform has a voltage of about IV peak to peak voltage, that is across 75 ohms as shown. That is shown in the figure, that is the 75 peak to peak, 75%. That is be located at some distance from the camera. A principle of the working and block diagram of color TV camera. Now we have a TV camera. The construction, working, and all things are same as CCD camera. So before going to start the particular camera, we'll learn about the fundamental of the color TV cameras. A color camera tube is used to split the optical image into the primary colors. Means any optical image is converted into the three primary colors. The special type of the mirror called dichroic mirror is used to split the image into the colors. So there is a camera dichromic mirror, and the light from the picture and lens assembly. This assembly, color conversion and natural density filters. Then we have a dichromic mirrors, and this mirror is converted the image or picture signal into the, or light from the picture is converted into the three output, that is the red cameras, that is the VR, green camera, VG, blue camera, VB. So red, green, blue, these three voltages developed through the three mirrors. That is the red dichromic mirror reflect the red colors and allow other color to pass through it. The scene is the focused by the zoom lens package on the dichromic mirror setup, and they are passed through the color filters. These filters can provide the precise primary color images. Each camera tube develops video signal voltage proportional to the color intensity received by it. A video preamplifier amplifies the VR, VD, VG. 3 voltage signal. In the output stage, a resistance network is used to generate the luminous signal and color signal. So resistance value are so related such that the luminous signal Y equal to the 0.3 R plus 0.59 G plus 0.11 B. If only red color light is focused, then we have only the red camera output VR. Then Y equal to the 30 upon 30 plus 70, that is VR equal to the zero point 0.3 VR. So this is the equation or the value of prominence signal. Picture tubes. In the next section, we have a picture tubes. So camera tube is a tube or device which convert the image or the light signal into the composite video signal. And picture tube is a device or tube as a CRT which develop the picture at the screen through the electrical or video signal. The side of the picture tube is generally denotes the diagonal length. The side of the picture tube ranges from 1 inches, that is to 30 inches or more. So 30 inch equal to the 76 centimeter, because the 1 inch is correspondingly completely 2.5 centimeter, equivalent to 2.5 centimeter. And so we have picture tubes of 1 inches to the 30 inches or more than 30 inches available nowadays. Most of the commonly used tubes in the black and white TV and the color TV are 51 centimeters and 36 centimeters screen size. And this size is measured in the diagonals always. So black and white TV is available into 51 centimeters, and the our color television is available in 36 centimeters screen size. The tube example is the tube 500 AMP4 has the diagonal length 500 millimeters, that is 20 inch. The last alphabet P specify the screen is the phosphorus screen. Another monochrome picture tube specification is given here, that the commonly used picture tubes manufactured in India and marketed by the BEL, that is Bharat Electronics Limited, are 310 C1P4, 470 C1P4, 610 C1P4, 590 C1P4 picture tubes employs the electrostatic focusing and electromagnetic deflection. So these monochrome pictures tubes are based on the electrostatic focusing and electromagnetic deflections. Now we have the constructions and working principles of monochrome picture tube. The picture tube is used to convert the video signal into the optical signals. We have already discussed that picture tubes are monochrome and color television picture tube, which is used to convert the received video signal into the optical signal. But a camera tube is convert the optical signal into the video signal. This is the difference between the picture tubes and the camera tubes. Now construction. In the construction, we have the main part of the monochrome picture tubes, that is electronic guns, focusing anodes, deflection coils, final anode, phosphorus screen, external conductive coating. So this is the image of picture tube, that is the monochrome type picture tube. And In this picture too, we have a cathode and anode. The base cathode will generate the electron beams, and it is focusing by electrostatic focusing, and some deflection coil is available for deflections, and this arrangement is into the glass envelopes. The cathode will generate the electron guns and electron beams, and this beam is uh, arrived at the phosphorus coating of screen. So inside of the screen we have a aluminized coating, and in between of the glass and aluminized coating we have a phosphorus coating. This is the important coating to display the pictures. And inner of the this tube we have an inner inductive conducting coating, aqueduct conduction coating. So we have a G1 and G2 and G3 is the control grids, accelerating anode, focusing anode, correspondingly respectively center magnetic and error magnets. We have here the EHT is equal to the 18 kilovolt, and some deflection coil arrangement is also in this picture. So this is the basic architecture of the picture tube for monochrome color television system. Now we will discuss the one by one part of picture tube. The electron gun unit consists of cathode, control grid, and accelerating anode. It is indirectly heated by a filament. Thorium, tungsten, or borium and strontium oxides are having low work function and so release a sufficient number of electrons of when heated. So in the electron guns, the electrons is generated by the filament. So cathode will generate and control the electron gun. The control grid is used to control the flow of the electron from the cathode. It is also in the form of cylinder and for flow of electrons. Screen grid is maintained at 400 volts and focusing grid is maintained at 600 volts. Through this base pin, only the rated voltage for different grids are supplied. Electrostatic method is used to focus the electron beam. The positive potential at the accelerating anode is extended. This is considered as first lens action. Screen grid and focus grid forms the second lens system. The focus anode is larger in the diameter and also its potential is higher than the first anode. The voltages given to the grid are so selected that the second convergence point is on the screen picture tube. Deflection coils. Electromagnetic system is used to deflect the electron beams in the horizontal and the vertical direction. So the deflection coils is available here to deflect the electron beam in the horizontal and vertical directions. A picture tube produces the horizontal deflection, and another pair of the coil placed left and right produce the vertical deflection. The two pair of the coils are collectively called deflection yoke. The deflection yoke, centering magnet and pin torsions magnet are also provided for centering electron beams. So this type of the deflection yoke maintain the electron beam in the center of the picture tube at the moment of electron beams at corners. Final anodes to provide the sufficient velocity and energy for electron beam, a final anode is included in the tube. This aqueduct coating is provided with a high voltage of 10 kilovolt or more. The secondary electrons emitted from the screen are attracted by these coating. Phosphorus aqueduct screen. The phosphoric chemicals are light metals such as the zinc, cadmium in the form of sulfate, sulfide, and phosphate compounds. The atoms, while hitting the coating, hitting spot fluorescence emit light. External conducting coating. Aqueduct is also coated on the outer surface of glass bell. A spring clip used to connect this coating with the chassis ground AC ripples in the high voltage and provide a perfect higher voltage. Now the working principle of our picture tubes, how the picture tubes are worked. An AC supply of 6.3 volt is given to the heater filament. This filament heats cathode and cathode emits the electron beams. The number of the electrons in the beam is controlled. The accelerating anode increase the velocity of moving electrons. A point and strike the phosphor coating on the screen. The accelerating anode increase the velocity of moving electrons. A point and strike the phosphor coating on the screen. The aqueduct coating inside the tube is given a high voltage in order of to 15 kilovolt. Because of the deflection coil current, the beam is deflected both in horizontal and vertical deflection. The useful video signal is given to the cathode control grid. It's called contrast control and brightness control. Due to the persistence of vision of eye, the viewer accumulates all picture elements as a whole picture. Phosphor screen. The phosphor chemicals are light metals such as the zinc, cadmium in the form of sulfate. The kinetic energy of the moving electrons in the beam are transformed to the atoms in the phosphor coating. External conductive coating is also outer the surface of the glass bell. Decay time of the phosphorus used in the picture tubes is approximately 5 milliseconds in the monochrome picture tube. Screen burn. It is a defect in the picture tube due to the electrons, but EHT voltage, extreme high tension voltage, is present for long time. Because of the absence of the deflection field, their electrons continue to strike. This defect can be overcome. Aluminized screen. A very thin coating of aluminium is provided on the back surface of the screen phosphor on all modern picture tubes. Means alumni coating is provided on the back side of the phosphorus or inside of the picture tube in the all modern picture tubes. The aluminum coating is connected to the high voltage anode coating. Aluminum coating reflects light from the screen. Types of the color picture tubes. First, we have a delta gun picture tubes. Delta gun picture tubes. Second is the precisions in line or gun in line picture tubes. Third is trinitron picture tubes. Three types of the picture tubes are available in the market for TV systems. So, screen of color picture tube is coated with three different color phosphor. However, three color phosphor are separated from each other physically. Now we have some multiple choice questions based on these discussion. First multiple choice question, which type of the amplifiers are used in the high level transmitter? A, class C type amplifier, class A amplifier, C, no amplifiers used, D, none of the above. Second multiple choice question, in digital TV, ATC conversion is done by, analog to digital conversion is done by A, PCM, B, EPCM, C, DM, D, EDM. PCM stands for pulse code modulation, differential pulse code modulation, and delta modulation, and adaptive delta modulation. So, in the digital TV system, which type of analog to digital conversion is done? In a receiver, TV receiver set, sound and the video signals are separated at the A, video detector, B, video amplifier, C, sync separator, D, IF states. Number 4, multiple choice question. The three primary colors in the dominance signal of a color TV signals are. In this lecture, we have studied the prominent signal, that is the signal Y. And the A is red, green, orange, B red, green, blue, C blue, green, magenta, D yellow, green, cyan. So, correct answer in this case is the red, green, blue is our prominence signal. A television system having n is equal to the 525 lines and p is equal to the 25 frames per second period has a horizontal sync frequency of A 50, B 15,625, C 625, D 525. Number 6, the signals sent by the TV transmitter to ensure the correct scanning in the receiver or called A, sync, B, chrome, C, luminance, D, video. Seven number question. Interlacing is used in the TV frames to A. Reduce the illusion of motion. B. Ensure the scanning of all lines. C. Avoid the flicker. D. Avoid the humming. This type of questions we have already discussed that the in the interlaced scanning uh, is used in the TV system. Interlaced scanning use the two fields in 625 line system. We generally use the 312.5 lines. So to avoid the flicker, interlaced type of scanning is used. Question number 8, the separation of the sound and picture carriers in our TV system is megahertz. A 5.5 megahertz, B 4.5 megahertz, C 6 megahertz, D 5 megahertz. In the channel bandwidth or TV spectrum, we have that 5.5 megahertz is the carrier in the TV system for separation of the sound and pictures. Question number 9. Equalizing pulses in the TV system are sent during A. Horizontal blanking, B. Vertical blanking, C. Horizontal retrace, D. Flickering. Question number 10. If normal line sync pulse width is 4.7, its width of equalizing pulse is it's A 4.6, 2.3, C 9.2, D 1.5. So the conclusion of today's lecture, today we have discussed the very important camera tubes, that is the CCD camera tube. In the CCD camera tubes, we have some limitations and we have some advantages. After discussing these advantage and disadvantage, we have the knowledge about the CCD cameras, and CCD camera has vast application in the area of scanning. These type of cameras tube or cameras are used generally nowadays in the malls, in the shopkeeper shops, or at the scanning of the books in the library. And these type of scanner is generally used to scan the barcodes. In the next section, we have discussed the very important part of TV system, that is the picture tube. It is the main part of TV receiver. How the picture tube is convert the electrical signal into the image. So we have discussed the construction or CRT type construction of picture tube. After that, we have discussed the working of CRT type picture tube. In this lecture, we have also discussed the types of picture tube. A part of the picture tubes and the CCD camera tube, in this lecture, we have discussed the color signal, how the color signal is produced by dichromic mirrors. Through the signal or electrical signal, the mirror is convert three voltages, that is the VR, VG, VB, correspondingly named as voltage due to the red colors, voltage due to the green colors, and voltage due to the blue colors. So through this lecture, student will understand the concept of the picture tubes, luminance, luminance and chrominance signal, and they also understand the CCD camera construction, working, and tubes. Thank you very much.